s equals socket.socket socket.afinet socket.sockstream. Now, AFINet is IPv4, sockstream is your port. If you've watched the videos on the buffer overflows that we've done, that's all it is. So you will have seen that previously. Hey Barner, thanks for the follow. We are doing Python lesson this week. This is a hacking course overall though. So we're going to say socket.set default timeout. I'm going to put it to 1 second, but I'm going to note for you guys that this is a float. So we could put in here 0.5 if we wanted to. We'll just do 1 second. But basically, if it doesn't detect that the port is open, then it's going to move on after a second. Or else it'll hang forever. Okay, and then we're going to restore our results in s.connect ex. And we're going to say target port like this. And all this does is this returns error indicator. So if there is an error on connection, it'll return an error indicator. If there is no error on connection, it returns 0. So with that being said, we could print out if result equals 0, then we know that we were successful in connecting. And then we can just format that here with port. And then we'll close the connection. Thanks for the kind words, Barner. I appreciate that. Okay, so I'm going to add in one thing here just for proof of concept. Typically, we wouldn't leave it in, and it's going to spam us a little bit. But I want to add in here that we're checking the port. So we know that it's actually running. Okay, so let's talk this through. So we're going to run a for loop. So for every number between 50 and 85, we are going to set up this connection right here. We're going to define the variable, which is just this connection variable, right? We're going to set a default timeout of a second. We're going to store our results. If we return an error on this connection, remember s.connect. So this is why we store this, because it would be socket.socket, all this in front of .connect ex. And we're going to say target port. So we're going to take the target that we declared up here in our IP address. We're going to take the port that we're declaring here in this for loop, put it through here every time. It's going to return our error indicator. Before we do that, we're going to print checking port. We could do that before the connection. We could say it up here if we wanted to, instead of having it down below. It doesn't matter where you put it. And then we're going to say if the result is 0, meaning that it is a success, we're going to print the port is open. We're going to format that port just so it fills in there all nice, and then we're going to close that connection, that particular connection we're going to close. We're going to run through this whole thing however many times, 50 to 85. Okay, let's declare some exceptions real quick. So a few things I want to declare. So we'll say except keyboard interrupt, and then we'll just print, make sure we add a new line here and say, oops, we'll say exiting program. So that way if we hit Control-C, we can exit the program and it'll tell us we've exited the program. And of course we need to say sys.exit, as we've learned. We're going to throw a couple more exceptions. If the socket GAI error, meaning that we cannot connect to the host name. Did I forget a colon? Where did I forget a colon? You tell me, I'll go back and fix it, because I probably did. So if we can't resolve the host name, we'll exit out. And lastly, we've got the colon for accept. It comes after keyboard interrupt. If we can't connect at all to anything, say the server's down, we'll just print couldn't connect to server, and also sys.exit. Okay, this is our shitty port scanner. There are lots of things wrong with this port scanner. This is I would say a version 1 when we're building something out. We come up with the concept, we say, okay, I know what I want it to do. And honestly, it wouldn't even look this good when we first do it, right? We may come up with okay, I know I want to define an argument, and if it doesn't work, great. We'll add the pretty banner. That's pretty straightforward. And we may not even put a try in. We might just put a loop in, right? We may even define a function or something else that works for this instead of putting this try statement in. But we could loop through this range and try the connection like we did here. And then we kind of have to figure out the exceptions as we go. Like we might try to hit Control-C if we're stuck and realize, crap, I didn't put a keyboard interrupt, so now I'm stuck, right? We would actually, if we were hitting Control-C without this keyboard interrupt, we would cancel the one loop and move on to the next loop. So you probably figure that out, and you would probably have an instance where the host name isn't resolved and it gets stuck or hung up. Same thing with the socket error. So it's all trial and error. And now we look at this and we say, okay, well, we could probably improve this again. We talked about putting argparse in here so that if we wanted to declare specific ports, we can do that. And if we didn't declare ports, then we can run through top 1000 or all of them if we wanted to, depending on what we wanted to do. So something to think about logically moving forward. Another thing that we're not doing here is that we're not threading. It is sockets.gai error. Sorry, let me put this down. I know I scrolled up. No capital on the G, though. And not sockets, just socket, all lowercase. So we need to do threading if we wanted to make this efficient, or else this is going to be slow as hell. And this is why we're calling it a shitty port scanner. We're going to run it. It may hang for a while before it even runs. If we do threading, then we'd be able to run multiprocessing, right, and allow it to actually do its thing and execute quickly. But we're not at that level of threading, so we're going to build this little port scanner like we just did, and we're going to try to run it. So go ahead and run it against your router or whatever you want. I'm running it against my router. You may find no ports. You may find some ports. So I'm going to say python 3 scanner.py, and my router is at 192.168.1.254. And you can see it's going through. Port 53 is open. My router is checking for DNS. Or my router is doing DNS. It's not risky. I've got DNS running. Heist 2000 is risky. Don't do it. All right, port 80 should be open. I have a web interface. There we go. So you see how slow this is, right? This would take forever. But if we do threading, we can run all these processes at once, or as many as possible that we could run at once. So just food for thought. And that is it. We are done. This is faster than your Nmap. I don't think it's faster than your Nmap. Your Nmap's doing a lot more than just checking if a port's open. Usually the top 1000 Nmap scan, that runs fast. So, welcome to week 4. We are covering the 5 phases of hacking, maybe 10 minutes, probably 5 minutes. It won't take that long. Then we're going to talk about passive recon or OSINT, and then we'll do the Q&A AMA like we always do. Okay, note. Please only use the information learned in this course for ethical purposes. From here on out, we are getting into the hacking phase of the course. So please stay ethical. Don't join the dark side. This is dark enough. With that being said, let's go ahead and cover the 5 stages of hacking. So stage 1 is reconnaissance. Now, reconnaissance is basically information gathering. So we have passive and we have active. I would actually consider active to be more of a level 2 or a scanning phase. Passive is when we do information gathering that doesn't involve the client or the entity itself, right? So we're going to be looking up maybe LinkedIn information or Google information, Twitter, Facebook, whatever we can to gather information, but we're not going to be attempting any scans on that server or scans against the host, etc. That's more of active reconnaissance, and I consider that to actually be scanning. So once we gather the information that we need, and we're going to be talking about phase 1 right now, and as we go through the course, we're going to hit hard on phases 2 and 3. We will touch on 4 and 5 as well, but as a pen tester, you don't need 4 and 5 as much. I'm not saying that they're not important, but we'll talk about how you would maintain access if you need to, and how to clean up when you're done with a pen test. Now, if you're doing red teaming, it becomes a little different, and 4 and 5 become more important if you're acting like you're an APT or something like that. So once we do phase 1, we're going to go ahead and go into phase 2, which is scanning and enumeration. This is your Nmap, your Nessus, your Nikto. Your Metasploit can do scanning. OpenVAS is a scanner. So we'll cover some of the different scanning tools, how to read those, what ports to cover, etc. as we get into that. I won't dive too much into that right now. And then gaining access. So once we do our scanning enumeration, steps 1 and steps 2, really step 2, I would consider probably the most important. But the more information and the more the more enumeration you do, the better off you are. So hacking is all enumeration. Enumeration. Even after you gain access, there's a whole nother level of enumeration, especially if you're just a low privilege user, or even if you have a domain admin account. Doesn't mean you have the goods, right? Just because you're domain admin, there still might be some information out there that you want or need, and you need to figure out where that's at and find it. So we're going to play a big part here, or do a big part in terms of learning how to scan properly and learning how to enumerate. But that will be later on in the course. But these are the most important lessons. I can show you how to exploit all day, but if you don't know how to find these things, you're not going to be a good pen tester, good hacker, etc. So once we do our scanning enumeration, we find a way in. This is called gaining access. So we gain access either through some sort of exploit, social engineering, etc. Once we have access, we want to maintain access, right? So we are looking for a way to maintain access in the network, not get detected, depending on how we want to do it. What if we have a session and something happens where they reboot the machine and we lose the session, right? How can we prevent that? How can we be on multiple interfaces and not get disconnected or detected? So we'll talk about that, and we'll talk about covering tracks as well. There's a lot of tools that we'll do that'll auto cover our tracks. So that's really useful. Like, for example, you'll see me use PSExec psexec uses SMB credentials to get a shell.